Hi, my name is Rawati Bowo. I'm ex-solutions architect at AWS. I also ex-software engineer at Grab and ex-infrastructure engineer at Sendit. So for these sessions, I want to talk to you about diving deep, VPC peering versus transit gateway versus internet gateway. So okay, who am I? So actually, I was 7 times cloud certified, so I already done all of the AWS associate certifications in just 3 months last year. So I already got the solution architect associates, sysops administrator associate, and the developer associates. I also have the foundational certifications like cloud practitioner. I also certified in Google Cloud, associate cloud engineer. I also have CompTIA Security Plus certifications. I was also certified in Terraform, associate Terraform. My work experience on the cloud is actually I was supposed to be an infrastructure engineer in database for about a year at Sendit, but I worked with multiple roles ranging from the full stack developer, database, DevOps, ITGRC, infrastructure architect, and performance engineer. I already saved like 5,800 monthly AWS spending by improving service implementations. So as long as Sendit exists, I already saved them 5,800 USD per month. I also work directly with the principal and staff SRE, spearheading infrastructure architecture issue because of transition from startup to scale up. I also create a new infrastructure baseline to handle limitations of using Microsoft netting while still comply with PCI DSS requirements. I also become a subject matter expert in database team for Terraform, Kubernetes, Argo CD, GitOps, and performance engineering. So the agenda is I want to show you a VPC peering demo, and then we're going to talk about the transit gateway demo, and then we're going to do a cost analysis. So I'm going to do this using Terraform. So as you can see, there is no resource on my VPC on the US East one. So let's start to build the world using Terraform. So actually, I was making a script to run this. I'll share the code later on. So we can just run the runner. So first thing, we want to deploy our VPCs along with the EC2 instances. So as you can see, the plan will add 42 new resource to my AWS account. You can check the implementations and implement it by yourself later on. So there will be 3 VPC, and each VPC have an EC2 instance which located on the public subnet, so that we can check using traceroute later on using the private subnet and the what's it called, the public using the private IP and the public IP. We can see the difference in latency. So yeah, it's still creating. Let's hope it can end soon. Okay, ready, done. So after we are building our infrastructure using Terraform on the VPC, we are deploying our VPC and the EC2 instances. We are going to build the VPC peering and modify. So as you can see on the instances, you can see 3 EC2 instances are created, and we are going to check our route table. Yeah, you can see in here the route table. Yeah, this is the route table. For example, in VPCA in public, we can see the destinations only have a local and internet gateway for the for the rest. Yeah. So okay, let's make our VPC peering. So I choose to get our VPC peering. So we can check our row table. So I'm going to, yeah, wait. We're going to wait for the VPC peering to appear. Still creating, and yeah, already done. So I'm going to refresh the row table. Wait, it doesn't refresh. Yeah, yeah, yeah. As you can see here, we have implement our VPC peering. Yeah, using this. Yeah, the target will be PCX because this is a peering connection. PCX stands for peering connection. So we are going to test the trace route and see the difference in latency. So for example, I connect to, yeah, so you can see in our instances, for example, I'm going to do some SSH to one of the instance. So for example, this one. Before we are going to do the SSH, I am going to change the privilege for the PEM key. So we are currently generating the key pair. So using C, so yeah. Okay, and we are going to SSH into our instances, our instance, or instances. Yep, I'm going to paste the public IP. Okay, yes. So this is, yeah, we already successfully SSH login to our EC2 instance. So for example, I want to check difference in latency between if we are going to do the trace route using internet gateway first. So for example, I'm going to trace route to this one using an internet gateway using the public IP. So the traffic will go to the internet, not inside the AWS. So you can see the difference in latency. For example, I'm going to do this trace route. Yeah, yeah. You can see it will take yeah, this kind of route. So it will take 11 milliseconds to do this one, and then 5 milliseconds, and then 6 milliseconds. So in total, it will have some kind of like 22 milliseconds to just do the trace route. So after this, we are going to do the trace route using the private IP. So you can see the difference in latency. So yeah, this is the private IP. We are going to do the trace route once more, but using the private IP. Yeah, you can see it only have one hop. Yeah, and latency is only half millisecond. So it's like 22 milliseconds versus half milliseconds. So it is 44 times higher in latency just to do the trace route. Yeah, it's really a huge latency. So after I'm showing you the VPC peering part, we are going to do next to the transit gateway. So actually the transit gateway part is made by my friends, Zeipei and Hyunsu. So actually I'm going to try this the first time. So I'm the one who's doing the VPC peering part, and they're the one who's using the transit gateway. So let's hope it is going to be okay. So for the operations, so yeah, we are going to close this and then check the operations once more. So I'm going to destroy the VPC pin connections. So I'm going to destroy this VPC pin connections, and then I'm going to apply the transit gateway attachment. Okay. Wait. Wait. Zero destroy. Wait. I think. Oh, wait. I think I. It should be five. Yeah. So it's five. Yep, it is right. And next, we are going to use three to make the transit gateway attachment. So actually, I really want to test the bandwidth. So we just, yeah. So I can show you the difference in bandwidth using like a performance benchmarking. I but I didn't know the tools, so I know that there is a key perf to do the performance testing for the bandwidth, but it is only available for the RHEL or Red Hat Enterprise Linux. So let's hope this transit gateway works. But because transit gateway will provision an additional instance for the transit gateway, it will take some time because it's creating the transit gateway. For VPC peering, it will not take a lot of times, since if you are using transit gateway, if you are using VPC peering, yeah, it's just a peering. It's like making a VPC behave like a subnet. So there is no an additional instance. So there is no additional cost. It will save a lot of cost. Yeah. While waiting, I want to show you about the cost analysis. So I'm using InfraCost to check the cost of the wait, still creating. Yeah. So let's jump into the cost first. So this is the cost. Yeah, this is the cost if you are implementing VPC peering. So I'm going to copy the path and then paste it here. So in VPC peering, uh, wait, this is transit gateway. Yeah, this is for transit gateway actually. For transit gateway, in VPC peering, there is no additional cost. So the total cost itself only $25. But if you are using a transit gateway, it we will have another a cost, which is the transit gateway attachment, which costs like 36.5 USD per month for each attachment. So if we have in this case we have three VPC, so each attachment will cost us $36.5. So it will cost you a lot. So use VPC peering if possible, since VPC peering will not have an additional cost. But the problem with VPC peering is there is a hard limit of 125 peering connections. So yeah, and it is non-transitive. So if you use VPC peering, you will need to make a peer. If you, for example, you have 10, you have 10 VPC that is wants to be VPC peering. So there will be 45, if I remember correctly, 45 peering connections each VPC. 45 peering connections that's taken, and each VPC needs to be paired with 9, yeah, with 9 other VPC. But if you are using transit gateway, it is a transitive route, so you only need to attach the VPC to the transit gateway. So you only need 10 attachment. There will no you will not manage a lot of peering connection, yeah, attachment. So but I already show you before how to avoid VPC peering by making one huge VPC and then making a lot of subnets in that VPC and do all of this, all the mesh using route table. It is really cost effective, and there is not many VPC peering that you need to manage. But there's a limitation of the number of subnets. Yeah, just an intermezzo. So wait, yeah. Okay. So actually the problem is I'm not able to do this because I'm lacking of IAM. So we are going to skip the part where we test a transit gateway. I'm really sorry, but yeah, I think I need another escalation of privilege to do this. But hope I can show you more. So actually you can run this and do it on your own. So for testing, you can just use traceroute. So that's all from my side. I'm actually open to work. Uh, yeah, I'm open to work. If you want to discuss something about the cloud, I am available. If you want to hire me as an employee, I also available. Yeah, just if you like this content, just subscribe and like and share because I think uh this is one of the most comprehensive comparison the the VPC peering versus the transit gateway. I also make this as an infrastructure as code to make it more easy for you to run the test and scale these things up. So thanks guys for watching. See you in the next video. Thank you. I am going to stop the record now. See you.